Cloud computing is a technology that enables users to access computing resources, such as servers, storage, databases, applications, and services, over the internet on a pay-per-use basis. Rather than owning and maintaining their own hardware and software infrastructure, users can rent computing resources from a cloud service provider and use them as needed. This allows users to avoid the capital expense and maintenance costs of running their own data centers, and instead focus on their core business operations. Cloud computing also provides greater flexibility and scalability, allowing users to easily adjust the amount of computing resources they need based on their changing requirements. The concept of cloud computing has roots that can be traced back to the 1960s, when computer scientist John McCarthy envisioned a future in which computing power and applications could be accessed as a public utility. However, the modern concept of cloud computing as we know it today began to take shape in the late 1990s and early 2000s with the emergence of internet-based computing and virtualization technologies. The term cloud computing was popularized in 2006 by Amazon Web Services, AWS, which launched its Elastic Compute Cloud, EC2, service that allowed customers to rent virtual servers over the internet. This was followed by the launch of other cloud services by companies such as Google, Microsoft, and IBM. Today, cloud computing has become a ubiquitous technology that powers a wide range of applications and services, from web and mobile apps to artificial intelligence and machine learning systems. There are three main types of cloud computing. Public cloud. Public cloud services are provided by third-party vendors over the internet, and the resources such as servers, storage, and applications are shared by multiple customers. These cloud services are often delivered on a pay-per-use model and accessible via web browsers or APIs. Private cloud. Private cloud services are operated and managed by an organization's internal IT department or a third-party vendor on behalf of the organization. This type of cloud infrastructure is dedicated to a single organization and can be hosted either on-premises or off-site. Hybrid cloud. Hybrid cloud is a combination of public and private cloud services that are integrated and can be managed as a single infrastructure. In this model, organizations can take advantage of the scalability and cost-effectiveness of the public cloud for certain workloads, while maintaining sensitive data and applications in a private cloud environment. There are also a few subcategories of cloud computing, including community cloud. Community cloud services are shared by a specific community of users with similar interests or requirements. For example, a community cloud service might be used by multiple healthcare providers to store and share patient data. Multi-cloud. Multi-cloud is the use of multiple cloud computing services from different cloud providers. In this model, organizations can optimize their costs and take advantage of the unique features and capabilities offered by different cloud providers. Serverless computing. Serverless computing is a cloud computing model where the cloud provider manages the infrastructure and dynamically allocates computing resources as needed to execute code in response to specific events. This allows developers to focus on writing code rather than managing infrastructure. Cloud computing has become a common technology in the IT industry, and is implemented in a variety of ways depending on the needs of the organization. Here are some common examples of how cloud computing is implemented in the IT industry. Infrastructure as a Service, IaaS. IaaS providers offer virtualized computing resources, such as servers, storage, and networking, that users can rent on a pay-per-use basis. This allows organizations to scale their infrastructure up or down as needed, without needing to invest in and maintain their own hardware. Platform as a Service, PaaS. PaaS providers offer a platform for developing, deploying, and managing applications in the cloud. This can help organizations to speed up their application development and deployment processes, and reduce the amount of infrastructure they need to manage. Software as a Service, SaaS. SaaS providers offer cloud-based applications that users can access and use over the internet. This can help organizations to reduce their software licensing costs and simplify application deployment and management. Hybrid cloud. Some organizations use a hybrid cloud approach, where they combine on-premises infrastructure with cloud-based resources. This allows organizations to take advantage of the scalability and flexibility of the cloud while retaining control over certain aspects of their infrastructure. Multi-cloud. Some organizations use multiple cloud providers to avoid vendor lock-in and gain access to a broader range of services and features. This can help organizations to optimize their costs and improve their resilience by spreading their infrastructure across multiple providers. Cloud computing offers a number of benefits to users and organizations, including cost savings. Cloud computing can help reduce capital expenditures on IT infrastructure and maintenance, as users can rent computing resources on a pay-per-use basis. This can be particularly beneficial for small businesses and startups that may not have the resources to build and maintain their own IT infrastructure. Scalability and flexibility. Cloud computing allows users to easily scale up or down their computing resources based on their needs. This can help organizations avoid over-provisioning or under-provisioning their IT resources, and ensure that they can quickly respond to changes in demand. Accessibility. Cloud computing enables users to access their applications and data from anywhere with an internet connection, making it easier to collaborate and work remotely. This can be particularly important for distributed teams and organizations with remote workers. Reliability and uptime. Cloud service providers typically offer high levels of reliability and uptime, with built-in redundancy and failover mechanisms. This can help ensure that applications and services remain available even in the event of hardware or software failures. Security. Cloud service providers typically offer robust security measures and compliance certifications, helping to ensure the confidentiality, integrity, and availability of users' data and applications. Innovation. Cloud computing enables users to take advantage of cutting-edge technologies such as artificial intelligence, machine learning, and big data analytics without needing to build and maintain their own infrastructure. This can help organizations innovate more quickly and stay competitive in their industries. While cloud computing offers many benefits, there are also some potential drawbacks to consider. Dependency on internet connectivity. Cloud computing requires a reliable and fast internet connection to access applications and services. If the internet connection is slow or unreliable, users may experience delays or disruptions in accessing their data and applications. Security and privacy risks. Cloud computing involves storing data and applications on third-party servers, which can raise concerns about security and privacy. Users need to trust cloud service providers to protect their data and applications from unauthorized access or breaches. Lack of control. Cloud service providers typically handle the management and maintenance of their infrastructure, which can limit users' control over their computing resources. Users may need to rely on the service provider to resolve any issues that arise, which can impact their ability to operate effectively. Cost. While cloud computing can offer cost savings, it can also be expensive for certain workloads or applications. Users need to carefully consider their usage patterns and pricing plans to avoid unexpected costs. Compliance and regulatory issues. Certain industries and geographies have specific compliance and regulatory requirements for data storage and processing, which may not be fully supported by cloud service providers. Users need to carefully consider whether their use of cloud computing is compliant with relevant laws and regulations.